Okay, hi again. Dr. P here, and in this lecture video, I'm going to talk about some of the material from Chapter 9, specifically more alkyne addition reactions. Now, one thing I wanted to do was to go over the hydration reactions that I mentioned in class on Friday. And we looked at two hydration reactions. One, excuse me, I'm repositioning things. I was able to move back into the office over the weekend, so it's kind of nice to have a little bit better space for recording these videos. Anyway, we saw a mercuration demercuration or oxymercuration demercuration. And it would look something like this. We'd have our alkyne, and the reagent that we actually want to use is HgSO4, so mercury 2 sulfate, HgSO4. We'll use water, and then we'll use acid as well. We'll use H2SO4. And what that gives us is this initial species here, which is called an enol. And then in the presence of acid, it will isomerize and give us our ketone. So our product is a ketone. And this is a Markovnikov addition. As I mentioned in class. So the ketone, the C double bond O, ends up on the more substituted carbon. We can also do a hydroboration oxidation. And I feel like this was supposed to be a slash and this was supposed to be a hyphen. Anyway, it doesn't matter. The key here is that we will go ahead and react this with some kind of hindered borane. All right, so we won't use BH3.THF. And hindered boranes one is dicyanamyl BH. Dicyanamyl is di-secondary isoamyl. So it's a boron with a hydrogen. 1, 2, 3, 4, 5. 1, 2, 3, 4. And each of these groups here, let me scoot that up a little. There we go. Each of these groups is an isoamyl group, and they're attached to the boron at that secondary carbon. So these are secondary isoamyl groups. Or we can use 9-BDN, which is a little funky, and it has a boron with a hydrogen, and then this is attached to this ring system, which is going to take me a minute to draw here. Hold on one sec. 2. Hold on here. Let me try this again here. Draw it a little different here. So where I have this broken line here, that bond is behind this bond in the front here. So 1, 2, 3, 4, 5, 6, 7, and 8. Whew. So this is 9BBN. Anyway, it is a hindered borane. And so we'll use a hindered borane, and then we'll go ahead and oxidize with H2O2 and OH minus. And that gives us now our enol. But notice it is an anti-Markovnikov addition. And then in the presence of OH minus, we will go ahead and get our aldehyde. And again, this is anti-Markovnikov. Okay, so I did want to mention the specific reagents that were used, namely for oxymercuration, demercuration, we use HgSO4, so mercury 2 sulfate, along with H2SO4 and water, 1 step. We still have to do the hydroboration oxidation in 2 steps, and we have to use a hindered borane. Now, if you wrote BH3.THF, and then wrote H2O2 OH minus, that would be fine. Okay. Now let's see here. The other reaction class or classes of reaction that I wanted to talk about were hydrohalogenation and halogenation. So let's take a look at those. So let's look at hydrohalogenation of an alkyne. And let's just go ahead and take RCCH, and we'll treat that with HX. And again, X could be, so X equals ClBr. Sometimes iodine. Sometimes iodine. Let's keep it to chlorine and bromine for right now. And we'll get R, C, double bond C, and we'll get an X and H. But this can continue to react. And so we'll get R, C, X, C, H. So we'd go ahead and get the dihalogenated species. Now we could instead do a halogenation. So let's just do Br2. We could do Cl2. Works with Cl2 as well. And we'll get R, C, Br, double bond C, H, Br. And then that can react further, and we'll get R, C, Br, Br, C, Br, Br, H. So now we have a tetrabrominated, a tetrahalogenated species. Now, a quick word about regiochemistry and stereochemistry. This guy, the hydrohaolgenation, is Markovnikov. And this one, the bromination, does add in this anti-type fashion here. So the bromines would be trans to each other in our initial alkene. Don't worry too much about forming these alkenes because the reactions tend to keep going. And remember that, bromine can add readily to a carbon-carbon double bond. So if you add bromine to a triple bond here, you're going to end up polybrominating. All right, so those are the additional reactions. And don't worry about these mechanisms because they're not necessarily well understood. And it's not like you're forming a bromonium ion or something here. So don't worry about mechanisms. And in the next lecture video, I'll talk about these reactions that we've seen, plus reactions from Chapter 8, and how we might try to put them together to do a synthesis. All right, well, until next time, stay safe out there. Bye now.